The idea with these is that you get some algebra that would have been just a simple matter of red dudes if it had had equal signs in it, but it doesn't have equal signs in it. It has these inequality symbols. So it might be these here. And what you do is do it in a couple of steps. First, you pretend that these were equal signs, and then you graph them. So I'm going to graph that, I'm going to graph that, and I'm going to graph that. Now, for reasons that I'll explain in a second, it's probably better to do them with dotted lines initially. So y equals 0 is just this. X equals 1 is this. And 2x plus 3y equals 6, that's done with a quick table, in other words by intercepts. So if x equals 0, y equals 2. If y equals 0, x equals 3. Look up the video on quick tables to see how I did that so fast. So anyway, 0 along 2 up, 3 along nothing up. Now, what you'll often be told is an instruction such as leave unshaded what satisfies all three of these conditions. Okay, so what you do is you find a test point that is clearly not on any of the lines. So, for example, 0, 0 is often a good test point. That's nowhere. Oh no, wait on. Sorry, that's on this dotted line. Let's go 0, 1. So that's my test point. And now what you do is, remembering that what's before the comma is x and what's after the comma is y, you substitute into these and you ask yourself, is it true? So is 2 times 0 plus 3 times 1, is that less than 6? Is 0 greater than or equal to 1? And is 1 less than 0? All I'm doing there is copying these out, but instead of an x, I write what's before the comma. Instead of a y, I write what's after the comma. The answer to that is yes, that is less than 6. Is 0 greater than or equal to 1? No. Is 1 less than 0? The answer is no. Okay, so our task was to leave unshaded what satisfies all three of those. So what we've discovered is that this point does not satisfy this condition. So therefore, we scrub out that side of the line. We just decided that the point did not satisfy this one. So we scrub out that side of this line, because we've decided we need to scrub out this point. And so that's why we have these two regions left. Now, we decided we did like the point from the point of view of that inequality, so we like this side of the line because that's the side that this point is on, so we don't like that side of the line. So therefore this region counts. I always recommending writing on this region counts. Now what about the lines? We had to leave unshaded what's satisfied. So does the line satisfy the condition? Yes, it does. Does the line satisfy this one? No. Does the line satisfy this one? No, because these don't have bars on them. So therefore I should leave unshaded this one. So that's good, but I should shade in those. Now, filling in the line is the equivalent of shading the line. So that boundary is filled in because that doesn't count. That boundary is filled in because it doesn't count. That boundary is not filled in because it does count. Finally, oh wait on, so I should write does not count. Does not count. And then counts. Now what about this? I always do the intersection points as well. Does not count. Why doesn't it count? Because that intersection point satisfies that, but it doesn't satisfy, sorry. No, it doesn't satisfy that and it doesn't satisfy that, so it definitely doesn't count. What about this? It satisfies that, but it doesn't satisfy that, so therefore that does not count as well. There you go, that's your answer.